Have you ever seen how a DC motor works? Or maybe want to know how to make one? Or maybe the applications of such motors in real life? Today, my group, consisting of Aston, Shivikram and Hanwei and I, will be presenting on DC motors, how they work and their applications. In addition, we will be covering a bit on how AC motors work as well.
First, we make a magnetic coil by wrapping a coated wire, copper wire, multiple times around the edge of the paper tube. Also note that a few centimeters of loose wire at both ends of the coil should remain uncoiled. We then proceed to remove the paper tube and wrap the ends of the wire around the coil at opposite ends of the circle. Tape can be used to keep the coil together, but it is optional.
After that, we start making the base. We use rubber bands to secure the paper clip to the side of the cup, and then place two ring magnets on the base of the cup after it's flipped. After that, we place a copper coil to rest on both the paper clips, allowing it to be over the magnet. Instead of using two magnets on one side of the base, one can be on each side to make it more stable.
After that, send the end of the wires at the base of the cup and connect them to the battery. Create outward facing hooks on the wires that face upwards, like in an S shape, where the one tail of the S is leading down back to the cup. Note that the distance between S and the base of the cup should be more than the radius of the coil and no more than 2 times the radius of the coil. Sand the coating off both free ends of the coil, after which use a permanent marker to insulate half the sanded areas on one free end, not both. Connect the battery to both ends of the paper clips and in theory, the motor should work. So how does this model work? It starts with a few basic principles like that of like poles repelling and unlike poles attracting, as well as inertia. The model consists of two main processes that are constantly repeating one after another to allow the coil to continuously rotate. The first is that when the circuit is closed and complete, the current flows through the copper coil and turns the copper coil into an electromagnet. The opposite pole of the electromagnet gets attracted to the permanent magnet. At the same time, the like pole of the electromagnet gets repelled from the pole of the top of the permanent magnet that is stuck to the top of the cup. This pulls the coil towards the electromagnet, completing half a rotation.
After that, there is a second part to the process. To record the construction process for the copper wire, one half of one of the ends resting on a paper clip was colored with a marker. What this does is that it acts as an insulator for half the circumference of the copper coil. Hence, when the copper coil rotates half a complete rotation, the insulated part gets exposed to the paper clip on one side of the copper coil, creating an incomplete and opening the circuit. This stops the copper wire from being an electromagnet. At this point, the half a rotation has just been complete, and the inertia of the copper wire causes the copper wire to rotate another half a rotation, allowing the completion of a full rotation.
After completing another half a rotation, the exposed part of the wire is now in contact with the paper clip, completing and closing the circuit, allowing the copper wire to once again be an electromagnet, and the process is repeated.
Most motors can be classified under DC or AC motors. Ours is a DC motor. There are a few differences between AC and DC motors. One of the main differences is that AC motors are powered by alternating currents or varying potential, but DC motors are powered by direct currents from sources like batteries. Also, there are differences in how they operate.
An AC motor works by having a coil that has its two ends constantly brushing against two wires, no matter how much it has rotated. An alternating current is a current that flips periodically, in that of a sine wave form, and has an effect of flipping the electromagnetic poles on the coil. Hence, when placed next to the two permanent magnets of opposite poles, it will constantly rotate due to the alternating current constantly changing the poles and constantly allowing the electromagnet and the permanent magnets to repel and attract.
An actual DC motor works by having two brushes brushing against the same loop, where the loop has two halves, each going to the negative and positive ends of a power source. Hence, when the coil is rotated, the brushing ends touch the opposite sides of the loop, flipping the current in the coil, hence flipping the electromagnetic poles, and when placed near two permanent magnets again, it will constantly rotate due to the constantly changing poles, and allowing the two kinds of magnets to repel each and attract.
Also, another kind of electromagnetic motor is the stepper motor. Here there are different numbers of magnets on the outer bracket as compared to the inner bracket. Hence, when a magnet on the inner bracket is attracted to one of the outer bracket magnets, there will always be some magnets misaligned on both brackets. When the current to the aligned electromagnet is stopped and the current to a misaligned electromagnet is started, the brackets realign themselves to each other, moving the brackets a fraction of a complete rotation. When this is repeated, a complete rotation is done over time.